to Science Fantastic with Professor Michio Kaku. Today we're going to talk about rocks from the sky, that is, meteorites. What are these things that we see streaking across the night sky, and what happens if one of them lands maybe on your backyard? With us today is Dr. Tim Gregory. He's the author of a new book about these things called Meteorites: How Stones from Outer Space Made Our World. And we should point out that he's a research scientist at the British Geological Survey in Nottingham in the United Kingdom, where we have him on the line right now. Well, today we're going to talk about the sky. What happens if the sky falls? Well, we're not Chicken Little, we're science buffs, and we know that these are rocks from space, but what are they? How old are they? Where do they come from? And what does it mean if you find something in your backyard that looks like a meteorite? Well, once again, with us today is Tim Gregory. The book is called How Stones from Outer Space Made Our World. So, Tim, first question for you is, how did you as a youth, as a young kid, first get interested in science, and then what steered you in the direction of astronomy and finally meteorites?
You know, I guess I was a very typical child. As a youngster, I was interested in loads of different things. I went through phases of being interested in, mushroom identification and bird watching. I've always been interested in space and astronomy. But one of my biggest interests as a child was geology. I was very typical. I had a geology collection. I used to like going out and collecting rocks and fossils, and I spent my pocket money on little gems. And growing up, I just ended up sort of drifting towards a degree in geology. And it was during my degree that I found actually you can combine a love for space with a love for geology in the form of meteorites, because of course meteorites are rocks that come from outer space. And so, meteorites are really the perfect thing for somebody like me because they combine my two biggest interests in life, space and geology. It's perfect.
Okay. Well, let's do a few definitions, first of all, especially for those people who watch the movies. We have comets, we have asteroids, we have meteors, we have meteorites. So give us a little, very simple definition. What is a meteor? How does it differentiate from a meteorite? What is an asteroid? And what is a comet?
Okay, I'll start with asteroids and comets because they're both objects in space. Now, asteroids and comets, they're very similar, in fact. They're both miniature worlds that orbit the sun, just like the planets. And the asteroids, you generally find the asteroids between the orbits of Mars and Jupiter in the asteroid belt. And the comets, they follow very strange orbits around the sun. They don't orbit the sun in nice circles like most things. They orbit in really elongated paths that we call ellipses. They're kind of like squished circles like eggs. And now and again, little bits of debris, little bits of rocky debris can get blasted off the surface of asteroids and comets and get sent into planetary space. Now, these pieces of rocky debris, they sometimes happen upon the Earth. And when they fall through the Earth's atmosphere, they light up incandescence, they burn, and they glow incredibly brightly as they fall through the atmosphere. These are meteors, and they're also known as shooting stars. So a meteor and a shooting star is exactly the same thing. And most of the pieces of rock that streak through the Earth's atmosphere, they actually get burnt up on their fiery passage, and they never make it to the surface. But the rocks that do make it to the surface, they're the meteorites.
Okay, and what about comets? Because comets can linger in the sky for days, weeks at a time, and become the source of myths and legends.
Oh, they can indeed. So it's quite interesting because one of the things that sort of come about the last sort of 10 years of research into comets and asteroids is that there actually isn't that much difference between comets and asteroids. There was this sort of traditional view that comets were basically dirty snowballs. They were mostly made of ice with bits of rock in there. And the asteroids, on the other hand, they were very rocky and they contained very little ice, very little water, things like that. But it actually turns out that rather than having these two very distinct populations of celestial bodies with the comets on one hand and the asteroids on the other, actually these celestial bodies exist along a really wide spectrum, and there's no real clear-cut definition between an asteroid and a comet. But the comets that you're talking about that you can see in the night sky, these are often called great comets when they're particularly spectacular. And the reason you can see them in the night sky is because now and again comets orbit incredibly close to the sun during their path around the sun. So they sweep very close to the surface of the sun where it's really hot, and their surfaces boil and issue forth gas and dust into space. And it's this gas and dust that gets lit up. It's a sort of tail behind the comet. And like you said, they can grace the night sky for weeks and sometimes even months. They're absolutely spectacular. And they've inspired myth and legend for hundreds of millennia, probably since before humans existed. We've been looking at comets in the sky.
In fact, you start your book talking about ancient history, starting with King Tut and the Egyptians. And when they unveiled King Tut's tomb, they found evidence of a meteorite. So could you elaborate?
They absolutely did. So it's a remarkable thing that wrapped inside King Tutankhamun's linen was this beautiful dagger. It was about the length of the forearm, and it was wrapped into his linen close to his chest on his left shoulder. And it's this beautiful dagger that's got this golden sheath. And it turns out that the metal from which this dagger was forged is actually metal from a meteorite. It's a metallic meteorite that's made mostly of iron. And this is really interesting because King Tut's dagger actually predates the Iron Age by several thousand years. And so the first encounter that our species had with iron, which is one of the elements that really underpins our technological civilization, our first encounter with such an important element was in the form of a meteorite. And so it's not just modern scientists that were interested in meteorites like myself. It was also the ancients that used them to craft sacred artifacts, which is just wonderful.
Now, some historians and scientists have pointed out that the grave sites of ancient Native Americans thousands of years ago, that at the top of the grave site you find meteorites, a collection of meteorites. And some people have said that Mecca, if you go to Mecca in Saudi Arabia, and people, of course, worship the Kaaba there's a meteorite, a stone on which Prophet Muhammad then leaped into heaven. So meteorites, they're part of our religion and our ceremonies, right?
Absolutely. You know, the pages of human history, all since the ancient times, since the ancient Egyptians, all the way, the Native Americans thousands and thousands of years ago, all across the globe, meteorites, they litter the pages of human history. These are objects that have captivated humans across the world.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Tim Gregory, author of a new book, Meteorite: How Stones from Outer Space Made Our World. And we have him all the way from England. He's a research scientist at the British Geological Survey in Nottingham in the United Kingdom. Well, where we left off, we were talking about how the ancients viewed meteorites, these stones from outer space that land on our backyard. But now we have meteorites that actually whiz across the night sky in modern times. So tell us a little bit about the Russian meteorite. Chelyabinsk was ground zero for a meteorite just a few years ago, and 100 years ago, back in 1908, Tunguska in Russia, once again, was the place where a giant meteor or comet slammed into the Earth. So could you elaborate?
Oh, gosh, Chelyabinsk. It's one that I remember. I was actually in class when I heard about that. I was in a physics lecture as an undergraduate. Strangely, we were learning about orbital dynamics, and then Chelyabinsk fell out of the sky. And it fell over this town in Siberia. And Chelyabinsk, it was quite a big one. And the scary thing about the Chelyabinsk meteorite is that nobody saw it coming. And despite the fact that it sort of slipped under the radar, literally slipped under the radar, it caused millions of dollars worth of damage to infrastructure in under a second, and it hospitalized people. The strange thing about the Chelyabinsk meteorite was that it exploded a couple of miles above the surface of the Earth before it landed, and the explosion actually, it burned brighter than the midday sun for a few seconds. So this was an incredibly energetic event. And the scary thing is that nobody saw it coming. You know, there were millions of dollars worth of damage in this town of Chelyabinsk, but can you imagine how much damage would have been done to property and potentially even human lives if a meteorite decides to Chelyabinsk fell out of the sky over one of the major US cities or a large European city or any big city for that matter? These things, you know, as well as being objects of scientific interest, they are a hazard to human civilization, and they're something that we should take very seriously when we think about our long-term future.
Now, when we look at the devastation caused by the Chelyabinsk meteorite, people call them city busters, capable of knocking out an entire city. But 100 years ago, back in 1908, in Tunguska, we had another giant meteorite, perhaps even larger than the Chelyabinsk one. Its impact was so great that people actually heard it hundreds of miles away. So could you tell us a little bit about the Tunguska impact and also the Chelyabinsk meteorite?
Yeah, sure. So the Tunguska impact is a strange one, and, you know, it's still somewhat shrouded in mystery. Because, like you said, it was one of the loudest sounds ever recorded, and it flattened trees for hundreds of square miles around the epicenter of the explosion. And yet, pieces of the impactor have never been found. Not so much as a single rock has been found. And so the exact nature of the celestial body that caused the Tunguska event about 100 years ago is still actually not very well understood. It's a bit of a mystery and a bit of a head-scratcher. I would love to know the answer as much as anybody else. But in terms of the Chelyabinsk meteorite that fell in 2013, we do have pieces of that meteorite. In fact, it's quite a funny story because the entry of this meteorite through the Earth's atmosphere was captured on dashboard cams because it happened to fall at rush hour in the town of Chelyabinsk. And because so many people caught it on dashboard cams in their cars, its trajectory through the atmosphere could be calculated quite precisely, and therefore its landing site could be calculated. And within a few days, this meteorite was found. Actually, I should also say that this meteorite did fall through the ice in the frozen lake. And so while the landing site was discovered, the meteorite itself wasn't recovered for a few months. But now this meteorite resides in, well, there are pieces of it in museums across the world. And I was lucky enough to look at a piece of it during my PhD project as well. And it's since gone on to be a bit of a world wonder because it made headline news across the world and a scientific delight.
Now, there are meteorite hunters, people who go out there and search for these things. And I understand that the South Pole, Antarctica, where you have lots of white ice and snow, is a great place to find these things because they stand out like a sore thumb. And also the desert. So could you explain to us where we find these things, the South Pole, deserts? If you are a meteorite hunter, where do you go?
Yeah, that's absolutely right. It might be the last place you'd expect to go looking for meteorites, right, the South Pole. But it turns out that Antarctica is a fantastic place to look for meteorites. So just for some perspective, we have about 60,000 meteorites in the worldwide collection, dotted about in museums and universities and curation facilities. And of that 60,000, about 40,000 of them come from Antarctica alone. So well over half of all known meteorites come from Antarctica. And there are a couple of reasons why Antarctica is particularly good for meteorite hunters. And just like you said, Antarctica is very bright. There's lots of ice, and so it's quite white. And meteorites are quite dark rocks, and so they stand out like sore thumbs on the surface. But there's also this remarkable property of the Antarctic ice sheet in that it flows over time. As snow falls in the center of the continent, it spreads out under its own gravity, and it flows towards the ocean at the edge of the continent, just like a natural conveyor belt. And as meteorites pitter-patter down onto the ice sheets over millennia and over millions of years, in fact, the meteorites become entrained in the flowing ice, and they get taken along for the ride on this natural conveyor belt. And there are certain areas in Antarctica where the ice all gets dumped and the meteorites get dumped along with it. And in these areas, meteorites accumulate in astronomical numbers. And it's these places where meteorite hunters go looking for them. And of course, the desert as well is a good place to go looking for them. Although the desert doesn't flow, it's kind of funny because if you're in the middle of the desert and you come across a rock, there's not really anywhere else apart from the sky where the rock could have come from. And so you don't have to go sorting out the meteorites and the million other non-meteorites before you find one. So the desert's a good place to find them too.
Okay, now let's say that you're looking in your own backyard and you stumble upon a rock that looks quite different. It's pitted. It looks like some of the meteorites you see in museums. How do you tell? How do you tell a meteorite from a fake, a meteorite from the real thing, and a meteorite just from a piece of rock that happens to look rather strange? Is there a way that an amateur can tell?
So that's a really great question, and the answer is sometimes. So just like Earth rocks, there are many, many different types of meteorites. And there are some meteorites that are very obviously alien because they look and feel quite unlike anything else that you might find on the Earth. And the best example of this type of meteorite is the iron meteorite because, like their name suggests, they're made mostly of iron, which means they're incredibly dense and they're really strongly magnetic as well. But the truth is, for most meteorites, it's very difficult to tell that it's actually a meteorite without looking at it. You need a trained pair of eyes, usually in a local museum or a local university department. Somebody might be able to help you out. But even then it can be quite difficult. And to really prove the extraterrestrial origin of something that you might suspect is a meteorite, you have to delve into its geological character under a microscope and its precise chemical composition. Because down there on the geological and the chemical level, these rocks that look just like ordinary rocks reveal themselves to be anything but. They're actually very strange, and they have chemical signatures that you just don't normally find on the Earth. And so it can be quite difficult. And so, I recommend getting in touch with your local museum or university department, or send me an email as well, and someone will be able to help you out if you think you found a meteorite.
Okay. And also, you mentioned the types. What are the different types of meteorites, and what does that mean if most meteorites, let's say, came from the asteroid belt?
Right, that's a great question. And it turns out that of the 60,000 meteorites that we've got in the worldwide collection, there are two main types of meteorites. There are two great families of meteorites. Now, the first family are called the chondrites. And the chondrites originate from asteroids that never melted when the solar system was forming.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, with us online from England is Dr. Tim Gregory, author of a new book, Meteorite: How Stones from Outer Space Made Our World. Well, when we last left off, we were talking about the different types of meteorites. There's more than just one type. So what are the different types, and what does that mean about where they came from in outer space?
Turns out that the different types of meteorites actually shed quite a lot of insight, and that they solve a lot of the mysteries about the different types of asteroids. And there are two great families of meteorites. So the first family are the chondrites, and the chondrites are a family of meteorites that originate from asteroids that never melted. And because these asteroids never melted, they preserve the primordial dust from which the solar system coalesced 4.5 billion years ago. And so by studying the chondrites, these primitive meteorites, we've learned not just about the asteroids from which they originate, but we've learned about the raw ingredients that you need to make asteroids and planets and the solar system itself. And then the second family of meteorites are the achondrites. And achondrites originate from asteroids that did melt. And in melting, these asteroids underwent entire geological transformation. They turned from coalesced balls of dust orbiting the sun into molten worlds, entirely molten. And these asteroids, they crystallize giant metallic cores in their centers, just like the Earth's core. And they have volcanoes on their surface. And so these were really fiery worlds. They were real infernos.
Okay, now, we talked about where asteroids come from, but some asteroids and meteors come from Mars. So how is it possible that we can have a meteorite from the red planet, Mars, on the Earth?
Right, so I'll never forget the first time I held a meteorite that came from the planet Mars. It was one of the most jaw-dropping experiences of my life to think that this rock that I'm holding in my hand actually came from the Martian surface. And a really good question, and it's a question that I asked my professor as well when I was an undergraduate student, was, how on earth do you know that this rock came from Mars? And it turns out that when these pieces of rock are ejected from the surface of Mars, they have within them tiny little pockets of gas. And this gas, it's locked inside these rocks. It stays locked inside these rocks during their interplanetary voyage to the Earth. And if we measure the chemical and the isotopic composition of the gas bubbles trapped in these rocks, it matches the composition of the Martian atmosphere perfectly. And then you might ask, well, how do we know what the composition of the Martian atmosphere is? And the answer is, well, we've got science laboratories on the surface of Mars. We've got the rovers. And it turns out that the chemical composition of the Martian atmosphere has been known for many decades. It was first measured by the Viking rovers that NASA launched. And so the gas in these meteorites matches the Martian atmosphere perfectly, which leads to the inescapable conclusion that these rocks originate from the surface of Mars, which is one of the most mind-blowing things that I think I've ever learned.
Welcome back to Science Fantastic with Professor Michio Kaku. With us on the line all the way from England is Dr. Tim Gregory, author of a new book, Meteorite, How Stones from Outer Space Made Our World. Where we left off, we were talking about the fact that Mars rocks apparently have landed on the Earth because they were blasted out of Mars millions and millions of years ago, drifted in space, and then landed on the Earth. Well, some people are now theorizing that there could be a ping-pong game. A ping-pong game between Mars, the Moon, Earth, and Venus, as meteorites plow into them, shower outer space with debris, which then land on neighboring planets. So maybe Earth rock will be found on the Moon. Maybe Venusian rock will be found on Mars. So what are your thoughts about the fact that our solar system could be a ping-pong game where maybe even DNA has been shared between the planets? What are your thoughts?
It's an interesting thought, isn't it? I remember once staying up quite late with my flatmates as an undergraduate. We were talking about whether Earth rocks made it to the Moon and whether one day you might find a T-Rex skeleton or an ammonite on the surface of the Moon that was blasted off the surface of the Earth. Now, it's quite difficult, it turns out, to get rocks off the surface of the Earth because it's so big. And because the Earth is so big, its gravitational field is actually relatively strong. The Earth is the largest rock in the solar system. It's the biggest terrestrial planet. And so it's the most difficult body to get rocks off the surface when it comes to its gravitational field. It just pulls them back down. On top of that, we've also got an atmosphere which slows rocks down as they get blasted off the surface. And so while it's possible that Earth is playing ping pong with Mars, it's probably just a one-way stream, actually, with Mars sending rocks to the Earth. However, occasionally in the scientific literature, there is a paper that's published that claims to have found a tiny fragment of Earth in a rock that comes from another planet or the Moon, for example. But they're still quite controversial and the case has not been settled. The jury is still well and truly out on that one. But it is interesting that we do find meteorites across the solar system. We've discovered meteorites on the surface of Mars with the Mars rovers, and the Apollo astronauts also discovered meteorites on the surface of the Moon. Although none have come from the Earth so far.
Okay, and then we had years ago a report that a Mars rock fell on the Earth. When you split it open, a microscopic analysis shows something that looks like microbial life, or maybe just a crystal. So what are your thoughts about the latest concerning that controversy about whether a Martian rock actually has remnants of fossilized cells?
Yeah, so this is actually a really interesting story, because I think that this particular meteorite, that in the early 90s, a group of scientists, they claimed to have found the fossilized remnants of Martian life forms inside this meteorite. I think that's one of the reasons why NASA still to this day is very, very focused on Mars missions, and why it hasn't really bothered that much with the other planets. It's all Mars, Mars, Mars for NASA. And I think that stems back largely to this particular meteorite. Now, at the time, there was a lot of controversy about this discovery. So this group of researchers looked at this meteorite under a microscope and saw what they thought was fossilized Martian bacteria. But there were quickly lots of counter-arguments from across the scientific community who actually recreated similar-looking structures.
Fantastic with Professor Michio Kaku. Once again with us today is Dr. Tim Gregory, all the way from England. His book is called Meteorite: How Stones from Outer Space Made Our World. Well, when we last left off, we were talking about, meteorites from Mars. Are they really carriers of potential life forms? Some scientists even think that maybe DNA may have come from Mars, in which case maybe we are the Martians. Well, let's move on now, because the granddaddy of all these meteorite impacts is what happened 65 or 66 million into the Yucatan of Mexico. So what happens when not just a city buster, not just a country buster, but a planet buster rams into the Earth, into the Yucatan of Mexico, wiping out the dinosaurs? What do we know about that object?
Yes, indeed. That was a bad day for life on Earth, because this particular space rock was about 20 kilometers across. It was the size of a city, and it plowed into the surface of the Earth at about something between 20 and 30 kilometers per second. And so this is really Armageddon level stuff. This is nuclear winter times 1,000. And it was likely that there were global fires that absolutely incinerated the land. There was so much ash and sulfur thrown up into the atmosphere that it blocked out the sun for a few years, and it caused climate change on a scale that makes today's climate change look like nothing. It changed global climate by tens of degrees incredibly quickly. And it took out the base of the food chain, which caused ecological collapse across the world. And it was one of the large mass extinctions that life on Earth has experienced during Earth's history. And it famously caused the dinosaurs to go extinct. But interestingly, for quite a long time, the exact cause of the extinction of the dinosaurs was unknown. It was only in the 1990s that people really came around to accepting the hypothesis that it was an asteroid that caused the dinosaurs to go extinct. And since then, we've actually found the giant hole that was punched into the surface of the Earth. It was in the Yucatan Peninsula in Mexico. And, the rocks there, when you look at them through a geological perspective, the rocks of the Yucatan Peninsula have been absolutely trashed by this asteroid. They're a complete mishmash. It's a chaotic jumble of debris, and you only really get that sort of thing happening when a giant asteroid strikes the surface of the Earth. So it was an incredibly bad day for the dinosaurs and lots of other species.
And I understand that people have now drilled into the Gulf of Mexico and retrieved what they think are actual samples of the meteor or comet that slammed into the Earth. What have we learned? What have we learned about mining operations that are now actually digging into the impact crater itself?
Well, it's fascinating, because because actually most of the asteroid was completely destroyed during the explosion. So just think about how much energy has to be released to completely destroy a piece of rock that's miles across. This rock is mostly completely vaporized, and very little of the original material actually still exists. But using the tools of science, you can recognize the chemical and the isotopic signatures of this rock, because of course this asteroid came from space, and so its chemical characteristics are quite different to Earth rocks. And so by teasing apart the rocks of the Yucatan Peninsula and other rocks from across the world that were affected by this event, you can tease out the characteristics of the asteroid. And we now know that the asteroid that caused the dinosaurs to go extinct, it almost certainly came from the asteroid belt. And it's a particular type of asteroid called the carbonaceous asteroid. And carbonaceous asteroids are interesting because they contain lots of water and lots of organics as well. They contain lots of complex carbon-bearing molecules, including amino acids, which are the building blocks of life. And there's a hypothesis that it was the same types of meteorites that delivered water and the building blocks of life to the Earth. And so there's a real nice sort of cyclicity to that. There's a nice contrast. You know, these meteorites, we've learned about our own origins and perhaps even the origin of life. But as well as the givers of life, asteroids are the takers of life too, because occasionally they crash into the planet called Armageddon. And, you know, like you, I'm very much in favour of humanity surviving far into the future. I really look forward to far into the planetary future, and a future in which an asteroid will hit the surface of the Earth is something that we're going to have to seriously contend with and take very seriously if we're going to survive in the medium and the long term. And the dinosaurs were proof of that. If only they had a space program, eh?
Yeah, the dinosaurs did not have a space program, but we do have a space program, and we also have lots of Hollywood movies like Deep Impact and Armageddon. But aren't they all fake? In the sense that we have no space shuttle that can reach deep space to intercept one of these rocks from space. And even if we could intercept one of these rocks from space, what do? Blow it up with a hydrogen bomb and then have lots of small meteorites hit the Earth? So what are your thoughts about what we should do, given the fact that these are planet killers?
Right, you're exactly right. We currently don't have the infrastructure and the technology to fly into deep space and intercept an asteroid that's on the collision course with the Earth. And I think that's really something that we should talk very seriously about fixing. You know, there are lots of global issues that humanity is facing right now in the year 2020. We've got environmental issues, we've got economic issues, but celestial issues are one of them. And I think, you know, this is, rather than being something that we should worry about, it's something that we should embrace. We should accept the responsibility of living on a planet that might be impacted and team together.
Okay. Well, Tim, we run out of time. Once again, the book is called Meteorite, How Stones from Outer Space Made Our World by Dr. Tim Gregory, research scientist at the British Geological Survey in Nottingham.